in what should be a win-win-win for the environment. A process developed at Rice University to extract valuable metals from electronic waste would also use up to 500 times less energy than current lab methods and produce a byproduct clean enough for agricultural land. The flash Joule heating method, introduced last year to produce graphene from carbon sources like waste food and plastic, has been adapted to recover rhodium, palladium, gold and silver for reuse. A report in the journal Nature Communications by the Rice Lab of chemist James Tour also shows highly toxic heavy metals including chromium, arsenic, cadmium, mercury and lead are removed from the flashed materials, leaving a byproduct with minimal metal content, instantly heating the waste to 3400 Kelvin, that is 5660 degrees Fahrenheit, with a jolt of electricity vaporizes the precious metals, and the gases are vented away for separation, storage or disposal. Tour said that with more than 40 million tons of e-waste produced globally every year, there is plenty of potential for urban mining. He noted an increasingly rapid turnover of personal devices like cell phones has driven the worldwide rise of electronic waste, with only about 20% of landfill waste currently being recycled. The lab found flashing e-waste requires some preparation. Guided by lead author and Rice postdoctoral research associate Bing Deng, the researchers powdered circuit boards they used to test the process and added halides like Teflon or table salt and a dash of carbon black to improve the recovery yield. Once flashed, the process relies on evaporative separation of the metal vapors. The vapors are transported from the flash chamber under vacuum to another vessel, a cold trap, where they condense into their constituent metals. The reclaimed metal mixes in the trap can be further purified to individual metals by well-established refining methods. The researchers reported that one flash Joule reaction reduced the concentration of lead in the remaining char to below 0.05 parts per million, the level deemed safe for agricultural soils. Levels of arsenic, mercury and chromium were all further reduced by increasing the number of flashes. Since each flash takes less than a second, this is easy to do, Tour said. According to the researchers, the scalable rice process consumes about 939 kilowatt hours per ton of material processed, 80 times less energy than commercial smelting furnaces and 500 times less than laboratory tube furnaces. It also eliminates the lengthy purification required by smelting and leaching processes.